There it is. Okay. So when we figure out similarity between objects, we can look at the proportion between the width and the length. I can set it up so it's width over length. So for A, my ratio would be 2 over 3.5. For B, my ratio, and again, it would be width, okay, which is 9, over my length, which is 15.75. And then C would be 2 over 5. To find out what that ratio equals, I just do the division. So what's 2 divided by 3.15? Okay? It's point something. So I go 2 divided by 3.5. It's 5.57. So if I do this work, which is, again, setting up the ratio between width and length, and if I did it the other way, I'm going to get the same, not the same decimal, but I'm going to get the same representation, except it's going to be length to width. If I do this, 9 divided by 15.75, I get 0.57.
Wow.
And if I do this, Mike, go recalibrate. Yep. If I do this, it's going to get 0.4. So this ratio between width and length, width and length, width and length will tell me if objects are similar. So because this ratio and that ratio equal the same number, and this one does not, I know that A and B are similar. Okay, Maddie?
Will it always be width over length?
You could do it the other way around too. I could set it up, I could compare length to width. Okay, if I do the length to width, here, that's going to be 1.75. And then if I did this, length to width, again, the orientation, I got to flip it. So I do 15.75 over 9. I'm going to get the same answer, because what it's saying is that this ratio and this ratio are equal. And that means that they're similar. And so the next thing it means is that they share a scale factor. Does anyone remember how to find the scale factor?
No. Wait, are all similar because they're all the same shape?
No.
Nope.
They're each different sizes.
So, let me change that one back, because that was...
Shape makes them similar.
So now, so we know that they're similar. We know that A and B are similar. So I'm just taking it one step further. Because they're similar, they have a scale factor. And I know one of the things that you're going to be asked to find is a scale factor.
Scale factor 5.7?
That's not the scale factor. The scale factor, the 0.75 is this side, the width is 0.75 the length of that. Okay? So because we did width to length, that's what that's saying, is that proportionally is 0.57 the length of that. Scale factor is saying how much bigger is this than that.
Oh, wait.
Smaller.
Okay. So to do, well, thank you. How much bigger is this to that? Thank you. So what I have to do here is set up another ratio. But this time I have to match corresponding sides. So if I do 9, what's the corresponding side of 9 over an A?
2.
2. And again, if I do 9 on the bottom and 2 on the top, this is saying how much bigger or how much smaller is A than B. Because I'm going to get a decimal here, right? And it's going to be 4.5. No, I got that wrong. Sorry. That's the other way. It's going to be 0.22 if I do this division. So what this means, is I'm going to, this here is 0.22 the size of B. Now it doesn't look it because these are not drawn to scale, but based on the numbers and doing the ratio of corresponding sides, this being A's width, this being B's width, A is 0.22 the size of B.
Like, is that much bigger?
It's that much smaller, yeah.
0.22 smaller?
Yep, it's 0.22 the size of B. So if I was to compare the other two, if I was to compare the length, which is 3.5 on A, to the length on B, this is also going to give me a scale factor of 0.22. The scale factor is going to be exactly the same. And the reason why is they are
So you just
similar.
divide the corresponding sides.
You got it.
How do you know how do you know if you're
Okay.
supposed to divide 9 by 2 or 2 by 9?
Great question. So, his question is, how do I know whether to divide 2 by 9 or 9 by 2? If I am going from a larger object, and I'm asking you, what's the scale factor from B to A? This is the larger object, right? This is the smaller object. So the scale factor is getting smaller. So we know the smaller number goes on top, the larger number goes on bottom. If I did it the other way, Josh,
Larger number would go on top.
this is telling, whoa,
Is that like
what happened
what
there?
you would do if you're trying to find how much bigger it is?
Yes. This is the scale factor of how much bigger is B than A. I put the larger number on top, and I divide it by the smaller corresponding side on the bottom. So this is 4.5, meaning B is 4.5 times bigger than A. And then A is 0.2 times smaller than
Could you just do a
B.
negative 0.22?
No, you wouldn't do negative.
Is that
I'm just trying to think. That's a good question, but it's not a negative comparison. It's still positive.
You can still a negative ones.
So ratios, corresponding sides. I want you to tell your partner what are the two ways that you can find out if objects are similar. Talk to your partner. Go. No, turn around and go with that. Casey, go with that.
Wait,
What are the two ways?
I'm not.
Now just go talk.
Or maybe you could
What are the two ways to find out if an object is similar? That shape will tell you if it's similar. Corresponding sides, corresponding angles. But what are the two ways I just showed you that you could find out if objects similar? Remember? Scale factor is one. What's the other one? Okay, so what's one of the ways that we can figure out if an object is similar? Like we just did one. Scale factor is one way, where we match corresponding sides.
similarities between
Okay.
shape.
And what's the last way?
Well, that was the question.
You can look at the shape, and if it's, you can get two shapes, and whichever one is more similar to the third one.
That's doing the proportion. That's comparing the width to length. Width to length. Yep, exactly. So by comparing our width and length on our shapes, we can find out if they're similar, and finding out the scale factor if they're similar. Questions about this? Okay, one last bit before we move on. You guys, I'm still missing quite a bit of work in here.